Every day and all around us, products are undergoing shock and vibration stresses. These stresses generally fall into 5 different categories: frequency, harmonic, random vibration, shock, and drop. Let's look at what happens if we don't design for these stresses. Tacoma Bridge, failure due to resonance. Boeing helicopter, works great in the air, but on the ground, its rotor speed matches the ground resonance. Philippines earthquake, foundation failure due to random vibration. Here is an airplane landing you don't want to have. Massive shock across all systems. Cell phones, yours and mine, we drop it every day. 1998 German train disaster, motor fatigue in one wheel leads to massive domino effect. These are extreme failures, but the products we design are accumulating incremental failure every day because of fatigue. This is where shock and vibration simulation can move you from good to great. And if that's not enough motivation, then just remember that because every consumer product has to meet meal standard, simulation can make that process easier, faster, and more predictable. Let's see how you can use SOLIDWORKS shock and vibration tools to design more robust product faster, better, and cheaper. To set up a shock and vibration analysis in SOLIDWORKS simulation, select New Study, then choose Frequency, Harmonic, Random Vibration, Shock, or Drop. Frequency analysis is the most fundamental dynamic simulation. It is used to determine the natural frequencies and mode shapes of a structure and to avoid resonance, which can lead to failures like the Tacoma Bridge. Here are the animated mode shapes of our smartphone and their corresponding natural frequencies. Let's talk about harmonic analysis. You should use harmonic analysis if your design includes rotating components. The object here is to make sure the rotating speed does not match the resonance of the supporting system. Our helicopter is a great example. If it was flying, it would not break up. But because it was connected to the ground and the rotational speed of the blades happened to match the resonance of the ground, catastrophic failure happened. This harmonic stress result as function of frequency shows which operating frequencies to stay away from to avoid resonance. When you think of random vibration analysis, just picture a car driving on a very rough road or the building falling in the Philippines earthquake. Every component of that car or building is being stressed by random vibration. With random vibration simulation, you can apply any number of power spectral density scenarios to your products and solve for statistical measures that dictate optimum design. For example, here, we are applying a mill standard 810 PSD curve to our smartphone to see if simulated stresses, displacements, etc. stay within the given tolerances. Look at this plane withstanding the forces from shock. This is an extreme example, but high-speed impact affect the products we use every day. Imagine if the landing gear had failed. In other words, shock simulation is critical for designing products that can withstand everyday abuses. Here, we are applying a mill standard shock curve to test a smartphone. And here are the stress results as function of time. Drop test is one of the toughest yet most common requirements for consumer products. Every day, we drop our smartphone in every conceivable way. With SOLIDWORKS drop tests, we can simulate different impact angles, heights, flow materials, and more to find weaknesses that we should design around. This German train disaster was due to a single fatigue crack in one metal wheel. The dynamic, repetitive forces had not been fully accounted for in its design. vibration fatigue calculates the incremental failure being accumulated by everyday products. Using fatigue analysis, you can determine whether your product is able to sustain the repetitive vibration level for a period of time and to avoid this kind of failure. You have just seen how SOLIDWORKS shock and vibration tools can be used to design more robust products, faster, better, and cheaper. Whether you are motivated to avoid disasters or to have your prototypes consistently exceed meal standard tests the first time, your use of SOLIDWORKS shock and vibration tools is the difference between your being good or great. Historically, most engineers use only static analysis, which you probably know is available in SOLIDWORKS Premium. The shock and vibration tools we talk about today are available in SOLIDWORKS Simulation Premium. To find out how easy it is to use these shock and vibration tools for your next project, I recommend that you contact your value-added reseller today.